So hello guys and welcome to the another video of data structures using Java. So in this video we will be solving a problem. Find the first node of the loop present in the linked list. In the previous video we solved the problem on detect the loop present in our linked list. But in this video what we need to do is, if our linked list contains a loop, we need to return the first node of that loop. For example, if you see this is the loop, we need to return this first node of our loop, that is 4. So this is a small problem, but I highly recommend you, if you haven't watched our previous video, that is how we can detect the loop, please go back and watch the video how we can detect the loop present in our linked list. Because if you don't know how we can detect the loop present in our linked list, these problems might feel some kind of difficulty for you. So let's begin with the solution of finding the first node of the loop present in the linked list. So as usual, we will be solving first the brute force solution and then we will try to optimize it slowly. So what we need to do is, observe carefully, what we need to do is, question says that simply return the first node of my loop. Whatever the loop which we have, simply return the first node of it. But the thing should come in your mind that in order to return the first node of your loop, your linked list must contain the loop, right? Your linked list must contain the loop. That is the reason why we first try to find, is my linked list contain a loop? If it is, we will try to check how we can return the first node of my loop, and if it does not contain a loop, we don't need to return anything. In that case, we will simply return the null because there is no in a loop. So how we can return the first node of the loop? So let's try to check how we can identify whether my linked list contains a loop or not. Okay, so what basically we will do is, we will try to visit every single node one by one, right? I visited 1, 2, 3, 4, 5, 4, 3, 7, 8, 9, and again I came into 4, again I came to this node, which means there will be one node which will be get visited for 2 times. There will be one node that will be get visited for 2 times. So can I say that if there is a node which is getting visited for 2 times, my linked list contains a loop, and this is also the starting point of my loop. This is also the starting point of my loop. Of course yes, right? Of course yes. If you see the 4 is visited 2 times, which means my linked list contains a loop and it is also the starting point of my loop. So what can help us, or which data structure can help us to check ki whatever the node I am trying to visit, have I visited that node earlier? For example, if I am coming at 1, I need to check, have I visited the node 1 earlier? If I come at 2, I need to check, have I visited that node 2 earlier? Of course you guessed it right, we can use the hash table, and we have used a similar tactics in our previous video to detect the loop in the linked list as well. So what I will do is, I will simply go to each and every single node one by one. That is, first of all I will go to 1 and I will check, have I visited this node 1 before coming to 1? How can I check this? I have simply kept one hash table, and inside my hash table I will check, is there any 1 present in my hash? You said no, which means 1 is not visited. It is visited for the first time. So simply I will put 1 into my hash. Then simply go to the next node, that is at 2. And again you will check, have I visited these 2 earlier? How you can check this? If the 2 is present in your hash, which means that node is already visited. So there is no any 2 present in my hash, which means my visiting that node for the first time. So I will simply put 2 in my hash and simply moving forward. Now observe carefully that I am not putting the values of the node, I am putting the whole node. I am putting the whole node because if you see carefully that our linked list might contain the 2 nodes of same values. Therefore we are not concerned about the values, we are concerned about the node which is pointing to some other node, right? If this is the node which is pointing to this node which is making us a loop, that is the reason why we are storing the node, we are not storing the values. So again I will check, have I visited 3 earlier? How can I check? I will check in the hash. There is no any 3, which means I haven't visited 3. So simply put 3 in my hash and go ahead, right? Then I came at 4, have I visited 4? How can I come to know? Check in my hash, is there any 4? No. So simply put 4, which means I visited for the first time, and simply move ahead. So in this way I will put all the nodes of my linked list inside my hash, that is 5, 4, 3, 7, I got 5, I got 4, 3, 7, so I done with this. Then I got 8 and 9, so I got 8, I got 9. So in this way from here I came at 4, from 4 to 3, 3 to 7, and then 7 to 8, and from 8 I came to 9, and again I came to this node. Now again I came to this node. Now I will check, have I visited this node? Have I visited this node? I am not saying the value, I am saying the node. I am saying the node. Have I visited this node? How can I come to know that? Check, my hash contains that node. My hash contains that node, which means there is one node I am trying to visit for the second time. Therefore, I can simply say that this is the node which is causing a loop in my linked list, and also it is the starting point of my linked list. Right? So this is the brute force solution we can use. So let's check the pseudocode for this, how we can help to find the first node of my linked list if it is contain a loop. So what I did is I simply kept a set which we call as a hash. So same hash we kept it, and observe carefully, I am storing the node. I am not storing the integer values, I am storing the whole node. Then I kept the pointer, temporary pointer, which is initially pointing to a head. Now see carefully that I am writing the condition temp is not equals to null. But you can say that Pramod, there is no any null in this. So how you are writing that temp is not equals to null? Array, there might be a case that your list does not contain a cycle. For example, this, right? So this list does not contain a cycle. So temp will come at 1, then it will go at 2, then it will come at 3, then it will come at 4, then it will be pointing at null, which means there is no any cycle in your list. Therefore, I have wrote the temp is not equals to null. And then what I did is, whenever I visit any node, I will check in my hash, have I visited that node earlier? If it is, I will simply going to return that node. If you observe carefully that I came at 4 and I checked, have I visited that 4 before this? You said yes, I have visited that 4 before. So you simply, this is the loop and this is the starting point of my loop as well. That is the reason why I am returning the temp, because I need to return the starting point of my loop in the linked list. Otherwise, I will simply push that node inside my hash and I will take my pointer to the next. And suppose if I come out of this loop, which means there is no any loop present in my linked list. If you see carefully, I simply came out because my temp is pointing to null, which means my linked list does not contain a loop. If it does not contain a loop, simply return the null. So this was the brute force solution. What will be the total time complexity for this? I am traversing the whole linked list, therefore it will take big of n time, and I am inserting into my hash and I am also checking into my hash. So it might take big of 1 or it can also take log n, depending upon the complexity and the total number of elements we are inserting. And what is the total space complexity? Total space complexity would be big of n, because we are inserting all the nodes inside my hash. We are putting all the nodes inside my hash. So this is the brute force solution to detect the loop present in your list. Now the interviewer will not be happy at all, because this is a brute force solution. He will ask us to optimize. So let's check us how we can optimize this code. So let's try to optimize this code. What we need to return is, that is the first node of my loop. In the previous video, we discussed one algorithm, that is tortoise on hare. The same algorithm we will be dealing over here, that is tortoise and hare, right? If you haven't watched the previous video, please go back and watch that video to get the clear idea on detecting the loop in your list. So what we need to do is, we know that we will be dealing with the 2 pointers, that is slow and second one is fast. Sorry, let me write it clearly. The slow and the second one is fast, and the fast will be moving by 2 position and the slow will be moving by 1 position. So what I will do is, I will simply keep slow and I will simply keep the fast, both are pointing to the 1. What we are doing is, first of all, we are detecting the loop present in my list, because only if there is a loop in my list, then and then only I can return the first node of that loop, right? Otherwise we cannot return the first node of my loop. Then I will simply move my slow by 1 position and I move my fast by 2 position. Move the slow by 1 position, move the fast by 2 position. Let me erase this, right? Again, move the slow by 1 position, move the fast by 2 position. Similarly, move the slow by 1 position, move the fast by 1 position. Move the slow by 1 position, move the fast by 2 position, right? Again, move the slow by 1 position and move the fast by 2 position, right? Let me erase this. Now again, move the slow by 1 position and move the fast by 2 position. Now if you observe carefully that we have already discussed in this previous video as well, whenever both the pointers are colliding, I will surely say that my linked list contains a loop. I repeat, whenever both the slow and fast will collide at the same node, I will surely say that my linked list contains a loop. Okay, we came to know that first thing, we have detected the loop. Now the big question comes in, how we can find the first node of that loop. The simple thing we can do is, any one of them, the fast and slow, any one of them, again bring back to the head. any one of them being back to the head. So simply what I did is I simply brought the slow to the head. Let me erase this and write it clearly. So the fast is pointing to the 7 and the slow is pointing to the head, right? So this is our head, this is our head, slow is pointing to the head. What we did is initially slow and fast was pointing to the 7. Then what I did is I simply took slow to the head and I kept the fast as it is. Now what we need to do is move slow and fast by one position, but both at the same time. I repeat, move the slow and move the fast by one position and both at the same time. So what I can do is I can simply move slow by one position and again move the fast by one position, move the slow by one position, move the fast by one position, move the slow by one position and move the fast by one position. And again there is one node, where both slow and the fast are pointing to the same node, and observe carefully that this is the node which is the starting point of my loop. This is the node which is the starting point of my loop, right? So I hope so you got the clear idea about how we can detect the loop. First point, need to detect, as I already wrote over here is, right, what we need to do is first of all we need to detect the loop, because only if there is a loop present in my list, then and then only you can return the first node of that loop, and then we need to return the first node of that loop if it is containing a loop, the loop. So initially both are pointing to 7, then I took slow to the head and I kept the fast as it is, then I moved slow pointer and the fast pointer by one position both at the same time until unless both are not pointing to the same location. Now both are pointing to the node 4 and this is the starting node of our loop, right? So this was the case if our linked list contains a loop. Now the big question comes in, what if our linked list does not contain a loop? So as discussed earlier that this is for the odd length and this is for even length. So I am going to perform the same slow and the fast pointer thing. So this is our slow and this is the fast, both are pointing to the head. So I will move the slow by one position and I will move the fast by two position. Again I will move the slow by one position, I will move the fast by one position. Now observe carefully that my fast is pointing to the last location, therefore I will stop, which means for odd length I have to keep on going till I am not pointing to the last node. I will keep on going only for the odd length cases. And for even length cases, this is the slow and this is the fast. So slow will move by one position and the fast will move by two position. Slow will move by one position, the fast will move by two position, and again the slow will move by one position and the fast will move by two position. Now observe carefully that in even case fast is pointing to the null. So in even case the fast is pointing to the null, so I have to keep on going till my fast is not equal to null. So this is the case where my linked list does not contain a cycle, whereas this is the case where my linked list contains a cycle. So I hope so you understood the approach and intuition how we can optimize the code to get the first node present in my list only if it contains a loop. Okay, so let's check out the pseudocode. So what I basically did is I kept the slow and the fast, both are initially pointing to the head. This is for even case, this is for even case and this is for odd case. What I need to do is move the slow by one position and move the fast by two position. And whenever both are equal, I will break out. Now see, coming out of this loop, there might be two cases. A case. Either if I have break from this or my condition becomes false. So if I am coming out of this, therefore my slow and the fast will not be equal. Because I am coming out because this condition has become false. And if this is the case, then this will never be a true. Okay. So if I am coming out of this loop because this condition has become false and the slow and the fast are not pointing to the same location, therefore simply I will return null because it does not contain a loop, right? If you observe carefully, here the slow and the fast pointers are not pointing at all at the same point. And if both are pointing at the same node, what we did is we simply took the slow again to the head and then we moved slow and the fast both by one position at the same time until unless both are not equal. And whenever both are equal, I will stop and I will simply return either slow or fast because both are pointing to the same node itself. So let's go on to the IDE and check the code, how we can write the code. So this is the code which I wrote. I took the slow and the fast pointer, both are pointing to the head. This is for even case, until unless fast is not equal to null, I will keep on going. And this is for odd case, if I am not at the last node, I will keep on going. I moved the slow by one position, I moved the fast by two position. The moment the both are equal, I will simply break out. Now coming out of this while loop might be a two cases, either because if this condition is getting false or you are getting break because both are equal. Okay, if both are not equal, which means my while loop condition has become false, which means there is no any loop in my list, therefore I will simply return null. Otherwise I will take the slow to the head and I will move the slow and fast by one position at the same time until unless both are not equal, and once they becomes equal I will simply return either slow or fast because both are pointing to the same node. So this was a small video on how to detect the loop and return the first node of my loop. Just in case if you are new to our channel, do subscribe the channel for more such informative videos. Till then, see you in the next video.